Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So in this session, we are going to analyze frame with side sway. Okay, so in moment distribution method, so we will apply the principle of superposition. So this is the diagram representing principle of superposition for side sway frame analysis. Okay, so based on this concept, this is the concept, and we have actually discussed this in the physical class. Okay, based on this concept, we are going to analyze one frame question. One frame question. So let's have one frame question. Okay, so we have frame A, B, C, D. We have frame A, B, C, D. Okay, so A is fixed, D also fixed. Okay, this frame is tend to move to right direction. Okay, so this is horizontal force. Okay, we label this as A. Label this as this is A, B, C, and D. Okay, and okay, there is UDL along member BC. So this UDL, the W is 25 kilonewton per meter. Okay, the point load is 200 kilonewton. Okay, A, B, C, D. So A fixed, D also fixed. AB is EI, and this one is 2EI. Okay, so this is side sway frame. Side sway frame because it is unsymmetry. Because it is unsymmetry. Okay, this is side sway frame because it is unsymmetry due to loading, due to both loading and geometry. Okay, so in order to analyze a side sway frame, because we have to understand that for the fixed end moment, fixed end moment has formula to calculate the moment due to external loading only. So loading only. And another one is due to side sway only, or due to delta only. So we have to uh to have we have to be able to divide this frame into two condition based on fixed end moment. One is due to loading, one is due to delta. Of course, due to unsymmetrical loading, the frame is tend to side sway to the right direction. Okay, to right direction. So we have to remove delta first. Okay, so now we have to apply. Okay, we are going to do this by applying principle of superposition. Okay, so the concept is like this. Okay, so whenever we want to analyze FEM due to loading, we have to put artificial support at C. Okay, so that we remove the delta. We remove the delta. So by doing this, we actually change the frame to properly restrained frame. So this is properly this is this is properly restrained frame, or we can also call this as fully restrained frame. Fully restrained frame. Okay, and another one is remain sideway frame. Remain sideway frame, but due to delta only. So due to delta only, so we will have this as well as this. Okay, so we have to measure the horizontal movement. Okay, the horizontal movement. Okay, the horizontal movement is the delta. Okay, so the horizontal movement, assume it move with the same amount at B and C. Okay, so we will start with the first step. So we have four steps. So we will start with the first step. Step number one. Step number one, we want to calculate K and DF. We want to calculate K and DF. K and DF. So, length. Length is given as previous. This is 4 meter. This is 6 meter. 6 meter. This is also 4 meter. Okay. So we calculate K in order to determine distribution factor. Okay, so looking at this frame, we have three elements, so we will have 6 end moment. Okay, so based on this, we will have 3 members, means that we have 6 end moment. Okay, 6 end moment. So the 6 end moment is start from MAB and then MBA. Okay, this is for member AB. This is for member AB. This is for AB. Okay, and we have MBC and MCB. So this is for member BC. And we will have MCD and MDC, and this two is for member CD. So we have 6 end moment. Okay, means that we have to have the 6 distribution factor as well. 6 distribution factor as well. So we calculate. Okay, we will calculate distribution factor. So we have to have AB, BA, BC, CB, CD, DC. Okay, we list all the end moment, 6 all together. Okay, and then we calculate K value. So K value, K. So I put EI here so that I can only put value. Okay, for AB, we will use 4 EI over L. The L is 4 meter, 4 EI over 4 lah. 4 EI over 4, it is equivalent to 1. This is for For EI have been put here. So it is 4 divided by 4. 4 divided by 4, this is equivalent to 1. Okay, for member BC, we use also 4 divided by 4. Okay, this is equivalent to 1 as well. And for member CD, the length is 6 meter. It is 4 divided by 4 divided by 4 divided by L. 4 EI over L. But don't forget, this has 2 EI. Okay, so we have 2 times with 2. It is 4 times 2 divided by L. It is 4 times 2. It is 4 times 2 divided by L. L is 6 meters. So this is 8 divided by 6. So 8 divided by 6, what is the answer? 1.33 ke? Is it 1.33 for 8 divided by 6? What is the answer? 1.33. Okay. So we have here. Okay, this is for member AB. This is for member AB. Okay. This one is for member BC. Okay, and this one is for member CD. And the answer is 1.333. So this is 4 times 2 divided by 6. Okay, this is 1.333. Okay, so next column is for distribution factor. Distribution factor. Okay, so AB is fixed, so it is 0 distribution factor. DC also fixed, 0 distribution factor. Okay, for BA and BC, since K for AB and K for BC is equal, so this is 0.5, 0.5. Okay, now, okay, please calculate for me. Please calculate for me what is the value for 1 divided by 2.333. 1 divided by 2.333. Total this. 1 divided by 2.333. So what is the value? 1 divided by 2.333. Please calculate. 0.429. So this one is 0.429. Okay. So we take until 3 decimal places. 429 is okay. Okay, so 1 minus 0.439. So 1 minus 0.43429, or 1.333 divided by 2.333. What is the answer? 0.571. Is this right? Okay. So this is step number 1. So step number 1, we calculate K and distribution factor. So this K and distribution factor, this distribution factor will be used in both step 2 and step 3. Step 2 and step 3. Step 2 is non sway frame analysis, and step 3 is side sway frame analysis. Okay, we move to step number two. Step number two. So for step number two, okay, step number two, this is side sway. Sorry, no side sway frame. We can also call is non-sway frame. Okay, this is non-sway frame. This is non-sway frame. So this is for table number one. Step number two for table number one. Okay, non-sway frame. Non-sway frame. Under this step, we have we have to do three things. Okay, number one, A, A, we have to calculate FEM due to loading. FEM. Okay, okay, FEM. This FEM we calculate due to loading. Due to loading. Okay, only. Okay, so we have to have the diagram, the frame. Okay, the frame. Okay, so this frame has fixed at A, fixed at D. Fixed at A, fixed at D. Okay, and loading, for the loading, we have 200 here and UDL. So the UDL is 25. The point load is 200 kilonewton per meter. Okay, and it has restraining force. Restraining force. Okay, here is pin support. So produces a restraining force. Okay, so this is R. Okay, so at support, we have to draw the free body diagram, means the reaction at A and reaction at D. So at A we have this is A, this is AX, and then we have AY. AY reaction, and then we have moment. So this is MA. Okay, reaction at the support. So we do the same for D. So we have, okay, the direction of AX and DX is up to you. Doesn't matter. You can put both move to both in right direction, both in left direction. So or you nak buat dia one to the right, one to the left pun boleh. Okay, so yang ni DX, this is DY, and moment. So this moment, okay, is MD. 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 Reaction at the support. So this is the frame that you are going to analyze under this step. Okay, you have to draw the frame. Put all the loading, and then put a restraining force. that is exist due to the artificial support at C. Okay, A, B, C, and D. And don't forget, we have to draw the reaction at each support, at support A and at support D. Okay, so looking at this, we have to calculate the fixed end moment for member BC. Fixed end moment for member BC. So we will have FEM for member BC, which is equal to negative WL squared over 12. And this is equal to negative W is 25, 4 squared divided by 12. Okay, so please calculate what is the answer. It is negative because of behavior. FEM due to loading. FEM for BC is negative. It is like this, yeah. This is P and C. WL squared over 12. WL squared over 12. So what is the answer? 25. WL is for WL squared over 12. What is the value? Okay, 25 times 4 squared divided by 12. What is the value? Okay, so it is 33.33. It is negative. Negative, yeah, negative. So this is negative 33.333 kilonewton meter. So another one, FEMCB will be positive. Okay, positive 33.333 kilonewton meter. Okay. Okay, next is 2B, step 2B. Step 2B, so we move to step 2B. 2B is to calculate end moment. Okay, we are going to analyze the frame in table. This is table 1. We are going to calculate end moment M not. Okay, so we will have a list of members. Start with join members kat sini. So we have AB, BA, BC, CB, CD, DC. Okay, so we have join A, join B, join C, join D. Okay, so we put distribution factor. This one is 0, 0, 0 0.5, 0 0.5, 0 0.429, and 0 0.571. Okay, and then the first moment in the table is the fixed end moment. Fixed end moment. Okay. Okay. So this is join member. Okay, FEM for member BC, FEM for member BC, it is negative 33.333 and positive 33.333. Okay, so we will start with this. So the first step is distribution. 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 Okay? Distribution. So we have to calculate this value and this value. Don't forget we have to distribute joint moment. So in this case, joint moment is 33.333 positive. So this 33.333 we times with 0.5. Okay, what is the answer? 33.333 times 0.5. 33.333 times 0.5. It is 16.667. Okay, it is positive. 16.667. Okay, 16.667. Okay, 16.667. Okay, next. Next is negative 33.333 times 0.429. Okay, next is 33. This 33. 33.333. Change to join moment is negative 33.333 times factor. 33.333 times 0.429. What is the answer? 33.333 times 0.429. What is the answer? This is negative. Negative 14.3. Negative 14.3. Negative 14.3. Okay, the other one? Okay, the difference between 33.333 minus 14.3. The other one, it is 33.333 times 0.571. Another one is 0.571. 19. Negative 19.033. Okay. Okay, then next step is carry over. We have to do balancing. Balancing. Okay, so the term is carry over. The factor is 0.5 because all alpha n is fixed. Okay, so we have to bring the value like this. Okay, bring like this, bring like this, bring like this. Okay, 16.667. 16.667 divide by 2, 0.5. The factor is 0.5. 16.667 divided by 2. 16.667 divided by 2. 8.334. So this is 8.334. This is also 8.334. Okay. Negative 14.3 divided by 2. Negative 14.3 divided by 2. Negative 14.3 divided by 2. It is 7 point. Negative 14.3 divided by 2. 15. Okay, and another one is negative 0.333 divided by 2. Negative 0.333 divided by 2. 19. 9.517. So 9517. 9517. This is 7. Okay, 9517. Okay. Okay, repeat the process. Distribution. Okay, 7.15 times 0.5. 7.15 times 0.5. We will get both positive. Okay, now we move to this. The joint moment is 7.15. The joint moment is 7.15. So we have to distribute into BA and BC. We times to 0.5. It is 3 point and it is positive. 3 point 3575. 3575. So this is 3575. 3575. Okay, next. 8.334. Negative, negative. 8.334. 8.334. Negative, negative. Okay, 8.334 times 0.429 times 0.571. 8.334 times 0.429. And another one is 8.334 times 0.571. Okay, times 0.429. What is the answer? Times 0.429. 8.333 times 0.429. Still 3.575. Is it same value? 3.57. 3.575. Okay, another one. This is 3.575, eh? Okay, 8.334 times 0.571. 8.334 times 0.571. 4.579. 4759. 4759. 4759. Okay, it is negative. 4759. 47559. Okay, so we move to the next step. It is carry over. Carry over. We carry the value like this. Okay, so 3575 divided by 2. 3575 divided by 2. 3575 divided by 2. Or times 0.5. 1788. 1.788. 1.788. This is also 1.788. And another one, 4759 divided by 2. This one, 4759 divided by 2. 4.759 times 0.5 or divide by 2. 2380. Okay. Then we repeat again the process. Distribution. Okay. Distribution. 1788 times 0.5. 1788 times 0.5. 1.788 times 0.429. 1788 times 0.571. Okay, the first one, 2.38. Bukan. 1788 times 0.5 dapat 0.894. 0.8994. 0.894. It is positive. 0.767. This one is 0.894 as well. This is negative 0.767. Another one. Another one. Yang ni. 1788 times 0.571. Negative 1.021. Okay. Okay. Okay, repeat again. This is carry over. Carry over. 0.894. 0.894 times 0.5. Divide by 2. 0. 0.4. 894 divided by 2. 447. This is also 0.447. 0.767 divided by 2. Okay. Okay, now 0.767 divided by 2. 767. Negative, yeah? Negative 0.3. Negative 0.3. 384. And another one is 1.021. 1.021 divided by 2. Negative. 1.021 divided by 2. This is 0.510. Okay. And then repeat another time. Distribution 0.3, negative 0, it is 0 positive here. 0.384 times 0.5. Okay, and then 0.447 times 0.429. And then 0.447 times 0.571. Okay, please calculate. 0.384 times 0.5. What is the answer? 0.384. Cepat. 0.384 times 0.5. 192. 0.192. 0.192. Okay, next 0.447. 0.447 times 0.429. 0.447 times 0.429. Negative 0.192. Okay, last value. Okay, last value. Ni negative. 0.192. Okay, last value 0.447 times 0.571. So we get negative. Negative here. 0.255. Okay, 255. Okay, so we have done 1, 2, 3, 4. Okay, let's do it another time. So carry over. Carry over. Okay, carry over. Okay. 0.192. 0.192 divide by 2 or times 0.5. This one, 0.096. 0.096. Negative 0.096. And last one, 0.255. 0.255 divided by 2. 0.255 divided by 2. So it is negative. 0.96. 0.128, yeah? Divide by 2. Divide by 2, we get 0.255. This one is, the factor is 0.5. Carry over the value. Yang ni berapa ni? 0.128, ya? 0.128. 0.128. 0.128. Okay, all is 0.5. All factor is 0.5. Okay? And then distribution. Okay, stop at distribution. Stop at distribution. So please calculate 0.096. Okay, the factor is the distribution factor is 0.5. 0.096 times 0.5. And then we have 0.096 times with 0.471. Okay, this is negative. And we have negative also 0.096 times 0.571. Okay, the first one, 0.096 times 0.5. 0.048. Okay, so this one is 0.048. 0.048. Okay, next. This one is 0.048. Okay, next 0.096. times 0.471. This is negative. 0.045. Another one is 0.0, 0.0. Is this 0.045? Yang ni? Is this correct? 0.096 times 0.471. Is this 0.045? Yang ni, is this correct one? 0.096 times 0.47. 4, sorry. This is 429, right? This is 429. 429, 429. Okay, 0.429 times 0.096. 0.041 or 45? 0.429, 41. 41, Okay, 41. Okay, 41. And another one is 0.0. Yang ni, yang bawah ni. 0.096 minus 0.041. 55. 55. 55. 0.055. Okay. So we can stop at distribution number 5. We can stop at distribution number 5. Okay, now we sum all the moment and we get M naught. We sum all the moment and we get M naught. Okay. Okay, please calculate. Okay, please calculate. Okay, please calculate this plus this plus this plus this. Okay. This is for AB, this is for BA, this is for B, C, CB, CD, DC. Okay, MAB. MAB. Please calculate MAB. 10,665, yeah? So this is M naught, 10,665. Okay, what about BA? MBA. 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 What is MBA? 21,376. 21,376. So should be negative 21.376. Okay. One negative, one positive, one negative. If you don't get the same, so please check back all the calculation. Okay, next. CB and CD. CB and CD. So please calculate for CD. CD berapa CD? What is the answer for MCD? What is the answer for MCD? So kira yang ni. MCD. MCD is negative value. So we get one negative, one positive. This is positive value. 2, 5, 1, 2, 3. 2, 5, 1, 2, 3. 2, 5, 1, 2, 3. Okay, what about DC? DC. DC, this one. DC, it is also negative. 12, 535. Okay. 535, 536. 535, 536. Doesn't matter. Okay. So this is all the end moment. Table number 1, this is M naught. M naught. So this is step 3, step 2, step 2, 2A, 2B, 2B. 2A we calculate FEM, 2B we calculate end moment from table, from distribution table. This is M naught. Okay, now we move to C. C. Okay, step 2C. This step we are going to determine restraining force. Okay, we are going to determine restraining force. Restraining force R. R. Okay, referring to this diagram as well. Okay, referring to this diagram. Okay. So we want to calculate R value. So to calculate R value, we have to write, the first thing is we have to write the shear equation, because we want to relate all the horizontal forces. This is horizontal forces. This is horizontal reaction. This is horizontal reaction, as well as R. So we link all this using what we call as shear equation. So we write the shear equation. Write shear equation. And shear equation ni is total Fx is equal to 0. Okay, total why shear is in X direction? Because when we analyze frame, we analyze the column. Column is vertical. Column is vertical. So vertical 90 degree, or the shear for vertical is in horizontal direction, Fx. So using the diagram, we write one equation. It is 200 plus Ax minus dx minus r equal to 0. Okay, that is why the diagram is very important. You cannot have this equation without diagram. You have to show the diagram. Okay, you have to show the diagram. You have to show your Ax, you have to show your dx. Okay, then only you can write the shear equation. It is 200 plus Ax minus dx minus r. Okay, then only we can get r. So in order to get r, we have to calculate another two unknown. So we have two unknown here, Ax and dx. Ax and dx. So for Ax and dx, we calculate Ax and dx using what we call as column analysis. So Ax and dx, Ax and dx, Ax and dx, okay, will be determined using column analysis. Using column analysis. Okay, means that you have to calculate, to analyze columns separately. You have to analyze two columns separately. So one for AB and another one for CD. One for AB, another one for CD. So this is A, B, C, D. Column only. Okay. And because this is this member AB has the moment value here. So member AB tu ada n moment. And n moment tu yang kita dah calculate dalam table. Okay. AB and BA. Dua-dua positif. Okay. So we have both positive moment. Okay. AB is 10.665. 665. This is MAB in the diagram. And we have MBC 21.376. This is 21.376. Okay, the length is 4 meter. And then we have here AX. This is AX. This is AX. So having this, by taking moment at B equal to 0, we will get AX. We will get AX. It is 21.376. 21.376 plus 10.665. This is just like you analyze, okay, simple beam using simple beam using static equilibrium. It is just like simply supported beam, but this is vertical. This is column, this is vertical. Okay. So we plus or minus? Minus. It is minus 4 AX equal to 0. So we get AX is equal to 21.376 plus 10.665. 665. So this is divided by 4. This is just static equilibrium. Okay, divide by 4. So what do you get? AX. What is AX? 21.376 MBA and 10.665 MAB. Okay, both are positive. Okay, we have to minus by 4 AX. So AX, the total moment, divide by 4. 10. It is 10. 8. 8.01. So this one is 8.01. So this is 8.01 kilonewton. So this is AX. AX, 8.01. Okay, we do the same for CD. Look at the table. So the table has this value for CD and DC. Both are negative. So this is n moment at C and n moment at D. So both negative. 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 And dx is acting like this. So this is dx. Okay, 25123. This is 25123 and 12535. This is 12535. 6 meter. 6 meter. So do the same. Do the same. So taking moment, this time MC lah is equal to 0. So it is okay. If you take moment at C, and the sign convention here is clockwise, so we get negative 25123 minus 12.535 plus 6 dx equivalent to 0. Actually, you don't have to show this. You don't have to rewrite and show all this. This is I want to show to you. So for the calculation, just give the answer. Okay, so this is dx, which is equivalent to 25123 plus 12535 divided by 6. What is the answer? What is dx? What is dx? 25123 plus 12535 divided by 6. 6276. 6276. So this is dx. Kilonewton. 276. Okay, kilonewton. Okay. So now this ax and dx is ax and dx, we substitute into the formula, into the shear equation. Not formula, shear equation. Substitute. You substitute ax equal to 8.01 kilonewton and dx equal to 6.276 kilonewton into the shear equation. The shear equation. Shear equation is 200 plus ax minus dx minus r. So it is 200 plus 8.01 minus 6.276 equivalent to r. So what is r? What is r? What is r? 200 plus 8.01 minus 6.276. What is r value? 201.734. It is 201.734 kilonewton. This is the restraining force. Okay. This is the process. For step number 2 and step number 3 has ABC, same thing. The difference between step 3 is only for A, because the next step 3, we have to assume FEM due to side sway. But table 2 for step 3B as well as R prime for step 3C, actually we just need to repeat the same procedure like this. Okay, so So for next step, I want to focus on how we get the fixed end moment due to side sway, and then you continue. Okay, so we move to step 3. Step 3, so this is step 2. Okay, now we will move to step 3. Okay, step 3. Okay, step 3, this is side sway frame. Side sway frame. Okay, so we have to draw the diagram. Okay, we have to draw the diagram. Okay. Okay, due to R prime. Due to R prime. Due to R prime. And due to R prime, there will be delta prime. Okay, so this one. Okay, so this. And this. The triangular. The triangular. Okay, delta is horizontal. The delta is horizontal. So this is the delta. Okay, this is delta prime. Okay, so this one has A, B, C, D. Okay, so we will use formula 6EI delta prime over L squared. This is the one formula to calculate FEM due to delta 6EI delta prime over L squared. And we will only have the fixed end moment for member AB and member CD. And for member BC, the delta prime is 0 for member BC because it moved horizontally. BC tu tak ada value sebab from B to B prime and C to C prime. So sini ada B prime, sini ada C prime. It move horizontally. There is no vertical deflection. So we only focus on the horizontal displacement for column AB and for column CD. Okay. So in order to do this, actually we can have two method. Okay, I show to you the first method first, and maybe for another question, I will show to you another one. Okay, so we have to assume FEM since delta prime is also unknown. Delta is unknown, delta prime is also unknown. So what we need to do is we have to assume FEM for one column. So let's say we assume, okay, step A, FEM, okay, FEM due to delta. Okay, we have to assume FEM for member AB and this is equal to FEM for BA. Okay, why it is equal? Because of the behavior. This is A, this is B, this is B prime. Okay, so this one is delta, this is L, B prime. Okay, because of the behavior, the fixed end moment will be applied like this. Okay, that behavior give us the sign. So it is negative, counterclockwise. So it is negative behavior. Negative behavior. And put 100 kilonewton meter. Okay, 100. Okay, it is negative 100. Okay, now we will apply this. We will apply this formula. Okay, we apply this formula. Okay, we do like this. Okay, 6 EI delta prime divided by L is 4 squared equivalent to negative 100 kilonewton meter. Okay, from this triangular, the angle or the chord rotation sini, this is called as chord rotation. Okay, chord rotation or the angle, the angle is positive. Angle is positive, FEM is negative. So the green is angle, the black is FEM. FEM is negative. Okay, so I put here positive for the angle. So this one representing chord rotation. Okay, it is positive 6 EI delta prime over L squared equivalent to negative 100. Okay, so yang ni actually tak letak pun tak apa. Tapi ada case yang you have to put the angle. Okay, so assuming that this is positive. Okay, so positive tak letak pun tak apa. Okay, it is 6 EI delta prime over L squared is negative 100. So 100 is the assumption and then we apply the formula. So we will calculate what is EI delta prime value. So this is negative 100 times 4 squared divided by 6. So what do we get? 100 times 4 squared divided by 6. Okay? Or just remain like this, doesn't matter. Just remain like this, doesn't matter. Okay, now we want to calculate FEM for member CD. So what we should do? We have to apply the formula. So FEM for member CD, which is equal to FEM for DC. Okay, then the formula is 6 EI, 6 times 2. 6 times 2 EI delta prime over L squared, 6 squared. Okay. Okay. So this FEM CD or DC is equal to 6 times 2 divided by 6 square, and this EI delta prime, we substitute. Okay, we take negative 100 times 4 squared divided by 6, substitute into this. Substitute. So what we get is negative 100 times 4 squared divided by 6. So solve this we get. So this 6 will be cancel. Okay, now FEM CD, FEM DC equal to. Okay, please calculate yang ni. 2, it is 2 times 100 times 4 squared divided by 6 squared. This is actually ratio, ratio. So kita nak identify the ratio between column AB and column CD. Okay, in this case, delta prime is constant, but the length is not constant 4 and 6. The EI is not constant, 1 EI and 2 EI. So that is why we will get different value of FEM. So please calculate. So it is 88.889, yeah? So it is negative 88.889 kilonewton meter. So this is the FEM. So this is the FEM. So next, we move to step 3B. 3B, we should repeat the same process. This is table 2. Table 2 is to calculate M prime. M prime. Same as what we have done previously. So we have to list all the members. ABBA, BCCB, CDDC. So this is FEM. Sorry. Distribution factor first. Distribution factor, FEM. Okay, distribution factor remain the same. 0, 0.5, 0.5, 0.429, 0.571. We just need to repeat the same, except FEM different, 0. Okay, so FEM for ABBA is negative 100. This is negative 100, negative 100. BCCB no value. CDDC is negative 88.889 and 88.889. And then we start distribute the moment. Okay. Can you can you continue? Because we just need to repeat the same process. Distribution carry over, distribution carry over, distribution carry over. 1, 2, 3, 4 carry over, distribution. Stop at distribution and then find the total. This is M prime. Okay, can you continue this? Okay, so we do this. So this is negative 100, we get 50, 50, yeah? Okay, 50-50, and we get 88.889 times 0. And it is 88.889 times 0.429 and 88.889 times 0.571 for these two value. Okay, so until this, can you continue to complete this? Can you continue to complete this? Because we have the same process for 2A, 2B and 2C, okay? As well as 3B and 3C. We just repeat the same, okay? So between table 1 and table 2, the difference is only for the FEM value. We have two table, one for non-sway frame and another one for side sway frame. The difference between these two is only uh, based on the FEM, because table 1, the FEM is due to external loading, and for table 2, FEM is due to side sway. Is due to side sway. Table number 2. Okay, means that you need to focus for step 3A in order to find the right FEM due to side sway. And FEM under step 3A will be based on assumption. We need to assume FEM for one column. Let's say the column that we assume is AB. Then we have to find the FEM for CD, for member CD. Okay, and it will be depend on the ratio. Okay, ratio of L, EI, as well as delta prime. Okay, so we get different value whenever L is not constant, EI is not constant, or delta is not constant. If everything constant, semua nisbah dia ratio dia 1 to 1, we will get the same value 100 as well. Same with the example given here. Nampak tak? Yang ni, this is for table 2. This is for table 2. Kenapa dua-dua column A, B and C, D has same negative 100 value? This is because L is same, delta is prime is same, okay, EI is also same. So that is why we get the same. So these two column actually we calculate by ratio. Okay, we calculate by ratio. Okay, so just continue. So yang ni continue. So continue 3B, 3B and 3C. And 3C. 3B and 3C. Sampai habis. And then move to step 4. Step 4. Step 4 is the final end moment. Okay, this is final end moment. Okay, the symbol is M final, and this M final is equal to M from table 1 is M naught plus correction factor R divided by R prime times with M prime. M from table 2. M from table 2. Okay, this is from table 1. This is from table 2. Okay, and then you just need to give the final and moment 6 value. Okay, you can summarize in table. You can calculate you can summarize in table if you want, or you can also just give like this. AB value plus R times value. So this is 10.665 for AB. So plus this value. Okay, so you will get MAB. So this MAB is M final. Okay, or if you want, if you can also summarize in table, You can also summarize in table. So list all n moment A, B, B, A, B, C, C, B, C, D, D, C. So you have M naught and M prime. So this is M final using the equation. M final is equal to M naught plus R divided by R prime times M prime. Of course, after you have determined R tadi 8.01, right? And then you repeat the same and you will get R prime values. Then you get the correction factor. So use this to calculate the final and moment. 6 value. FEM for DC in table 2, negative. Negative. It is all negative. Negative because of behavior. Frame, whenever the frame is tend to sway to right direction. Yang ni dia punya behavior. Okay. This is the frame after side sway. And the moment, the fixed end moment, we push this and this. And the behavior for AB and BC and CD is the same. Same. We have to push this. We have to push this as well. Okay, so both negative. Negative. So dalam table ni semua negatif. Negatif negatif. Okay, negatif. FEM AB equal to FEM BA is negative 100, and another one is FEM CD equal to FEM DC is also negative 88.889. Okay. Okay, that's all. Okay, that's all. So follow all this, complete complete the table 2, complete table 2 for M prime, and repeat the same process, step 2C, the same process we repeat in 3C to determine the restraining force. Okay, R prime. Then after that, we move to step number 4 to calculate the final end moment. The final end moment, M naught plus M. And M is R divided by R prime times M prime. Okay, and then you have to give the final answer. You can list one by one like this. You can list one by one like this as shown in the textbook. As shown in the textbook, it is just like this. List all the member. Okay, or okay, you can give in table form. Okay, table form like this. Okay, so list back all M naught and M prime. So you get M final. So that's all. So this is how we analyze frame with side sway. Okay. So make sure you complete this. Okay, complete this. Frame with side sway has 3 condition. Yeah. So this is the first condition. Another one is this. This is another one. This is number 2. And number 3 is like this. Okay, number 3 is like this. Number 3. So yang kita buat ni number one ya. Number one. Yang kita buat ni number one. Okay. So the procedure will be the same. The procedure will be the same. And for 2 and 3, 2 and 3 ni kat mana yang different dekat step 3 lah, dekat step 3A tu. Step 3A, nanti saya akan tunjuk example how we analyze frame type number 2 and frame type number 3. So the procedure will be the same. Okay, kat mana yang nampak complicated sikit dekat step 3A. So we will have session and I will focus for how to calculate, assume and calculate FEM under step 3A. Okay? So that's all. That's all for tonight. Thank you very much. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.